So today what we're going to take a look at is exponent rules and exponent functions. Now, recall, when we're dealing with exponents, it's just another way of looking at repeated multiplication. For example, if we took 3 times 3 times 3, we get 27. But we could also represent that as 3 to the power of 3. Punch that in your calculator, it would look something like this. 3. And then on your calculator, you would use either y to the x. Some of you would have something that looks like this. A caret sign to represent the exponent. Or some of you might have something like this. X to the box. And then you would type in the number 3, and it would do exactly what this thing did. So basically, if you think about it, we have 3 to the power of, say, 4 would just really be 3 times 3 times 3 times 3. That's all it really means. Now, when we deal with exponents, we're going to actually talk about the different kinds of rules. And the first rule that we're going to work on is this. We're going to actually test it out. So remember, just like we said before in our previous explanation, 3 to the power 4 is just 3 multiplied by itself exactly 4 times. Now what we'll do is we'll take a look at the multiplication rule of two exponentiated numbers multiplied together. In general, we have the following set up for every exponent. Let's say I have an example here. We'll just put it over this side. Let's say I have 2 to the exponent 6. We call this big thing on the bottom, let's all agree that this is what we call the base of the exponent. The base of the exponent. Now this thing up here, we are actually calling the exponent number. So this is just basic terminology that we'll be using for the rest of this unit. So now, if I have 3 to the 3 right here, I'm going to write it in red. That really means the following. 3 times 3 times 3. And I'm going to put the operation in black here, and then repeat the number 3 2 more times for our second operator in this binary operation. So 3 and 3. So as you remember from a long time ago and from our previous discussion about exponents, notice for this part here, 3 to the 4, there are 3 represented 4 times. So if I look at this overall picture right here, there are actually 5 3s. So we could actually write that as our final answer equaling 3 to the exponent 5, because we've repeated that 5 times. Now, another thing that you should remember when dealing with exponents is that the exponent is applied to the number directly beside it. Notice I didn't say the sign of the number or the number directly beside it. Or you need to recognize this. If an exponent is applied to a bracket, that bracket is repeated several times. So, for example, let's take a look at this. Just like before, we'll repeat this in red. So now this is 2, negative 2 raised to the power of 2. So this means we're actually going to have to repeat the number negative 2 2 times. just like before. We're going to write our operator as a black, red, and then negative 2 raised to the power of 4 means negative 2 repeated 4 times. Now, as you can see, the total number of 2's here is 6 of them. So I could replace all of that with negative 2. Notice, negative 2 is still in brackets, raised to the power of 6. Now, the general rule for multiplying exponents is we keep, now remember what I told you before, the big number that is that's being affected by the exponent, or the bracket that's being affected by the exponent, is called the base. So we'll actually just write that out. So we're going to say this is called the base. Now, if we multiply powers with the same base, that means we're going to keep the base the same, whether it be just a straight number or a bracketed number raised to a power. Keep the base the same. So we keep the base the same, and then we add the exponents. That's all you really need to know about multiplying exponents. So now we'll just do some practice. So let's not go and write all that extra stuff that we did before, where we did like took a number and just multiplied it, showed the multiplication over and over again. We're going to use this beautiful, beautiful expression right here in order to avoid ridiculous calculations and writing out massive numbers of work. So here's what we're going to do. We're going to write out our basic thing here. So if you take a look at our problem up here, it says if I have 2 different exponents but with the same base, all we're going to do is we're going to add the exponents as our result. Now, this problem says write them as a single power. To write something as a single power, all we do is we use that rule that we just have up here. So now we're going to write this is equal to 4 to the, well, 3 plus 3, which is equal to 4 to the 6. Now, all we have to do is just multiply that outside, multiply that 4 to the 6 times, or all we're going to do is we're going to apply our exponentiation rules. So we'll use that same thing that we did before, and I'll actually just copy it down. Basically, if we do this, we're just going to write, well, 4 on our calculator. Then we use one of these 3 functions that you might have. You might have a caret sign, you might have a y to the x sign, or you might have something like this, x to the blank sign, and then hit the key 6 on your calculator. And in this case, 4 to the 6 is equal to 4,096. We'll apply the same rules over and over again until we get it right. Now, you notice this next problem. We have negative 3 in brackets raised to some power of 5, and then times 3. Now, if there is no exponent on something that's repeated in our calculation, we automatically write an exponent 1. So we're just going to write that in so you kind of remember. If no exponent, write a 1. So in this case, our new equation is basically, remember, because we have it in brackets, we have to repeat the bracket. So we get negative 3, 5, plus 1 is equal to -3 to the exponent 6. And we'll apply the same rules that we used for our exponent here to get our answer here, over here. And punching that in, we get 729. Our next issue will be with dealing with fractions. Now, you notice for question C, we actually have two bases which are fractions, but they're raised to two different powers. So guess what? It's in a bracket, so we're going to use exactly the same rules that we did before. So we're going to keep the base the same, and we're going to write 2 over 3, and then we're going to raise it to the 2 plus 3. So that simplifies to 2 over 3 raised to the 5. Now, this is where a lot of you will fall. The key here is, because we have a fraction, 5 applies to both the top and the bottom, because 2 over 3 is in a bracket. So we get the following. When we drop the brackets, we get 2 to the 5 divided by 3 to the 5. And 2 to the 5 gives us 32. And 3 to the 5 gives us 243. The key idea is to realize that when you simplify the exponents first, then you apply the exponents to all parts of the number and get either your whole number or your fraction. Or, like our last problem here, C number 2, which should be D, we're going to have the following. Well, this is all going to be A to the, 3 times 4. So these are all just adding exponents. So we have A to the exponent 3 plus 5 plus 4, which ends up being just A to the 12. Now, because it is simply a letter value, we are done. Now we'll take a look at the division rule. You need to remember that anytime we take a look at a division, we could always look at a division as a fraction. And you know from our previous examples that 3 to the 6 is just 3 times 3 times 3 times 3 times 3 times 3. And 3 to the 2 is just 3 times 3. And we get something that looks like this. Now remember, the division could also be written as a fraction. So if you think about it, what's actually happening here is the 3 to the 2 on the second part of the operand for division goes on the bottom. And on the top, the 3 to the 6 is actually put there. So now what we can do is we can use the 1 rule, Mr. Simpson's 1 rule. Well, 3 divided by 3, isn't that just 1? So technically what happens is we're actually just canceling out these 3's. So the 3 on one of the 3's on the top cancels with one of the bottom 3's, and then another 3 cancels another 3 on the bottom. Now there's no more 3's. So in essence, there's just a 1 left on the bottom of this fraction, which means our final solution is just 3/4, 3 raised to the power of 4. Okay, now we can pause this, try the next problem, and you'll see what the answer is. we have this -2 repeated 7 times on the top because we have 2 to the 7 as our first operand for division. And then on the bottom we have -2. Notice it's in brackets still, raised to the power of 4, which means it's 2 to the 4. 2 to the 4, or -2 multiplied by itself 4 times on the bottom. And then we're going to use Mr. Simpson's Rule 1, which is cancellation. And we cancel matching 2's from the top and the bottom, and we'll get the following answer. -2 to the 3. Now, the rule for dividing exponents is simple. If we divide powers with the same base, we keep the base the same, and we subtract the exponents that are there. So, 4 to the 3 divided by 3 to the 3. Let's take a look at that, and we will use this beautiful equation that represents the subtraction of exponents. You'll see something like this on a test easily. This equation you might have to actually reproduce on a test, showing the general form. So, we will write 4 to the 3 and 3 to the 3 as 4 raised to the 3 minus 3. This is a special case. I want you to remember. This special case that I've come up with. Now, 4 to the 3 minus 3. So the 3 minus 3's cancel. You get 4 to the 0. It's not 1, it's 0. 3 minus 3 is 0. And when you punch this in your calculator, you get just 1. Anything to the 1. So anything to the 0 is 1. So example, if I had 3 to the 0, it's equal to 1. If I had x to the 0, it's also equal to 1. If I had a to the 0, it's also equal to 1. So anytime we have any division or addition, sometimes you get an exponent of 0. You just need to realize that when you have an exponent of 0, whatever comes out ends up being 1. If you're not sure, use your calculator and make sure that you punch it in. Now let's take a look at part B. We have -3 to the 5 divided by -3 to the 2. Now remember what I told you. Anytime we deal with exponents, the exponent that's here is applied to everything that's attached to directly beside it. It is attached to the number beside it, not the sign. The only time the sign comes into play is when the minus sign is inside a bracket that's being applied. So now we have the following. -3 to the, 5 minus 2. And that's pretty easy. That's -3 raised to the power of 5 minus 2 is 3. We use our calculator and we'll actually type in -3, and we're going to have to make sure that whenever we do this with negative signs, we need to put the negative sign in brackets, or else this whole thing fails each time. And then we write our y to the x on our calculator, and then we punch in 3, and we get -27. Now, a quick way to make sure you know if you've got this right, you notice that this power is an odd power, right? If you have an odd power being applied to a minus number inside a bracket, the overall will always be negative for odd number exponents. It's just a quick rule. Just remember, if you have a negative base, the overall is going to produces uses a negative in the end. Okay? You need to remember that. You'll see something like that on a test, I guarantee. Now, for these last problems, we're going to apply the same rules that we did before. Let's go through it. So, just like before in the multiplication, we keep the base the same if everything is the same in our problem. Now, our base in this problem here is just 2 over 3 in brackets. So we're going to write 2 over 3 raised to the power of, well, 4 minus 2. And then we end up with 2 over 3 raised to the power of 2. Now, this is the hard part. A lot of you guys tend to forget that once I've got my fraction raised to a single power, we're going to apply the 2 both to the top and the bottom portions of our fraction when we drop our brackets. So we get 2 to the 2 divided by 3 to the 2. 2 to the 2 is 4, and 3 squared ends up being 9 when you punch that in your calculator. Now, as for the last problem, I want you to try to remember what happens when we have a bunch of multiplications or divisions and one of the bases are missing an exponent. I'd like you to try and compute this last equation that we have here. Let's see what you get as your simplified answer, and I'll put that solution up. Pause right here and try it on your own. Now, just like before, if you remember, we always made sure that there was a 1 existing on something if it didn't exist on our base. If the base was missing a number 1 or there was nothing there, we always put an exponent 1 above it so that we know what to do next. So notice we have 2 divisions. So we have a to the 5 divided by a to the negative 2 divided by a to the 1. So what we can do is we can write it all in one shot. So we write a to the 5. Now, because we have a division by 2, that means we're subtracting 2. And then the next division occurs, which means we're going to subtract again 1. When we simplify, we get a to the exponent 2. Now, you just got to recognize that since I have a to the 2, there's nothing to do. There's no value for a. So we're done. We're going to have a homework quiz once we get to lesson 5. Basically, what we're going to do is eventually we're going to do a lesson based on the first 4 units. When we get to school on Monday, I suspect what we'll do is we'll do a practice set of questions. Your homework is these sets of questions. Good luck, guys.